Hello, you should be able to hear me now. Yes. Hello,
Hello,
you
you
should
should
be
be
able
able
to
to
hear me
hear me
now.
now.
Thank you VIT Bhopal and Professor Sriram for helping organize this session on VFX Graph using Unity Editor. Today is May Day and I appreciate all of you attending this session for it really shows that you are very much interested in game development. My name is Arvind Neelakantan and I'm the head of technology for Unity India. Everyone loves blowing up stuff in video games, and I used to think that making a few hundred explosions using the particle systems was a lot of fun. Then I made a million of them at the same time, and it was way more fun than earlier. With Unity's VFX graph, having millions of particles at the same time on the screen is now possible. This is because VFX graph creates particles that are simulated on the GPU, as opposed to the inbuilt shuriken particle systems which are simulated on the CPU. Since doing calculations on the GPU is much faster, you can create a lot more complex simulations with a huge amount of particles. Something that makes VFX graph very powerful. Additionally, it is also includes a fully node-based tool. This is actually quite similar to shader graph, and that means you can add, delete, edit nodes to make cool looking particles. This means that you have a very powerful artist-friendly tool to create some amazing effects. Another cool thing is that external assets such as point caches, vector fields, and signed distant fields or SDFs can also be used to create visually stunning effects. So let's dive right in because I don't really like showing slides. So for today's webinar, let me close that. So for today's webinar, while I was thinking what to teach, I realized that Star Wars Day is really 3 days away. It's on May 4th for people who don't know about it. And what better way to celebrate Star Wars Day than having blasters? So this was a simple scene I put together. We have stormtroopers in this scene, all of them shooting blasters, and you can see the blasters coming out of the gun. It's not necessarily aligned really well because that's not the point of this. So you should be using your imagination a bit, and you can see all of the blasters blasting out. And as soon as the end of the blaster's lifetime comes to an end, you can see particles or sparks just flying around, and they fall off. Blaster effects are a great way to teach VFX graphs since it teaches you how to create all kinds of other effects as well. We'll also be talking about GPU events, which is very powerful to string effects together so that different aspects or different effects are spawned one after the other. We'll split the blaster effects into three parts. One, the initial blast that you see right here. You see the little sparks where that is generated when this plasma energy is being created. The second part would be generating the plasma beam itself. And finally, we'll look at explosions. Before we get started, one thing you need to make sure that is you're running 2018.3 or later. You should also ensure that you're using either the high definition render pipeline or the universal render pipeline. As you can see, I'm running 2019.3. I'm going to open up the package manager, which you can see right here. And also just ensure that you have the visual effects graph already installed. It is usually auto installed when you use high definition render pipeline or HDRP. So we are now ready to use VFX graph in our project. So how do I create? Let's go to my a working scene which essentially just contains a line of stormtroopers just waiting to fire off. Going to right click, create visual effects graph. I'm going to call this pew pew VFX because that's the sound that usually gets made when you are shooting blasters. I'm going to drag the VFX that I just created, drag and drop it into my hierarchy. You'll notice that Unity automatically creates a game object with this effect, and it has the visual effect component attached to it, which references our visual effects that we just created. Right away you can see that there are some particles that are being generated right here. We also need to do one other thing, which is we need to go to Edit, Preferences, click on Visual Effects, and ensure that experimental operators and blocks are checked, because this enables us to use GPU events, which is an integral part of today's lesson. I'm going to close that. I'm going to open up the Pew Pew VFX, which I just created, and as soon as I double click it, it will automatically open up the VFX editor. As with any other window in Unity, you can dock it anywhere in the UI. So you can dock it here, but I'm going to dock it to the side so that I can see it a lot better. And if you have already used shader graph, you should be very familiar with this interface, because very similar to the shader graph, it also has a blackboard on the left hand side and the editor area itself on the right, which I'll talk to you about next. So the left hand side you have the blackboard, right hand side you have the huge space where you can add the nodes and edit the VFX itself. Navigating around it is also very similar to shader graph. You can use the middle mouse button to drag, or do the same thing with the alt and left mouse button. You can also scroll to zoom, and if you want to focus on some node, you can select the node, click F, and that will also automatically focus. And if you want to see all of the VFX graph editor, you can click on A, which will focus everything. So what we are seeing here is a structure for a basic particle system. It contains a chain of contexts which are each responsible for one aspect of the system. So let's go through it one by one. On the top, we have spawn. In this context, we can tell the particle system how many particles we want to spawn and in which way we want them to go. That is either in bursts, or should they be going on constantly, as you can see right here. So if I change this to 1, for example, it will only generate one particle at any given point of time. Below it, we have the initialize context. The initialize context allows you to set up initial values for each particle emitted, such as how long the particle has to live, what color does it spawn with. We can also set the capacity, which is how many particles our systems can handle, or even the bounds for our particles. We can change the properties of our particles during runtime, which is over time, such as position, rotation, size, and so on, in the update context. We can use even forces such as turbulence, torque, gravity to change these values over time. And finally, how each particle is rendered is defined in the output context. We can choose from points, lines, quads, or even meshes or decals to render our each individual particle. So currently, as a default, it shows a quad. Now each section inside the VFX graph is called a block. A block is just a small chunk of logic that can be added to the context to do a specific task. So take for example, the initialized particle, we have a few blocks here. Let's increase the constant speed rate to 16 again, as it was. If I set the set velocity random block and we tweak the behavior, let's say we will if I just make them all 1 1 1 1 1 1, then you'll notice that the selected velocity random is now being only in one direction, which is all of it is in the is only been given in one direction. and you can also delete it, and that will automatically stop adding that context or adding that block logic to our particle effect. You'll also notice that you can also add blocks. Adding blocks is quite simple. You select the context on which you want to add the blocks. So in the update particle, if I want to add a block, I'm going to press space. It will open up a menu. The cool thing about the menu is that it is context aware, which means it will only present options that actually make sense in this context. So let's add some gravity tools. So I'm just going to search for gravity. I'm going to add some gravitational force, and you'll notice that automatically gravity is applied to all of my particles. You'll notice that our FX automatically updates because our VFX graph is set to auto compile, as you can see right here. One thing to note that the values that you change in the node will automatically update regardless of whether you have auto turned on or turned off. So let's say if I turn off auto and I change the value of gravity to, let's say, plus 9.81, it hasn't compiled it because the node value was the only thing changed. But if I delete this by clicking on delete, you'll notice that the gravity is still applied. So if I remove gravity, it won't really update. You can of course manually update it by clicking on compile, or simply turn on auto compile, and that should also work. Additionally, in order to help you with some basic FX, Unity also provides some inbuilt graphs. You can access them by right clicking, create node, and if you go under system, you have about 7 different particles FX that are default graphs that help you get started. For example, if I select the simple heads and trails, it will automatically create a graph that will help me create these trails for me. This could be your building blocks to start creating FX for you. Alright, so let's start creating the blaster FX. So I'm going to select everything. I'm going to delete it, so I don't want anything. Let's click on compile, and there should be nothing because there is nothing. I'm going to right click, create a sticky node, and I'm going to create a simple particle system. Click on auto so that it auto compiles. Alright, so to begin with, we don't need this many particles. I only need, remember when I told we are splitting this into three parts. One is the flash that comes out of the blaster, the plasma beam, and the explosion. So this is only going to be talking about the flash. For the flash, I don't need this many particles. I only need a flash of a particle. So I'm going to change the spawn rate in the spawn context to 1. I only need 1 of them. Next, I don't want the flash to really move around as it does right now. I just want the flash to appear and then disappear. So I'm going to set all of the random velocity that is by default there to set it to 0. I'm going to set it all to 0. Set it all to 0. Now you'll notice that the particle only shows up over there. Typically, one other thing is the blast has too much of a life. So I'm going to reduce the blast lifetime because the flash shouldn't be appearing for so long. So I'm going to reduce the lifetime of the flash to be a lot less. So I'm going to make it about 0.3 to 0.4. So randomly, this is the lifetime of that blast itself. It just goes bam, blast, and then goes away. One other thing you'll notice is that the blasts increase in size and then they should disappear. In order to do that, I'm going to go to the update context, which is right here, because that's something that happens every frame. And I'm going to add a block, and I'm going to call the block called add size over life. What this does is it will create a particle and it will increase the size of the particle as the life of the particle increases. Now, of course, one thing I really don't like is the default look of the particle. This is the default material that's available on the particle. So I'm going to go to the output particle quad, which is where the final rendering or the final look of what you want to be having is shown. So I'm going to go to my output particle quad. and I'm going to add a color. Going to remove this component and I'm going to add a color. Let's add color. Now add a color. You'll notice that there is really not much of a difference. Also the size is huge, but we'll fix that in a bit. So I'm going to add color, and when I select the color addition, it opens up this HDR color palette. I'm going to select an orange color. Really doesn't make a lot of difference, but the blast usually is a flash of light. So I'm going to increase the intensity of it so that it really is showing up well. And while you're doing this, if the glowing effect really doesn't show, then that's because you need to add the bloom post-processing effect on top of your scene. To add the bloom, as you can see in my hierarchy, I have the post-process volume. If I go to my inspector, I have the bloom set up over here. If I change the intensity of it, you'll notice that the bloom effect also increases. Post-processing effect itself is a separate topic, so I'm not going to delve too much into it, but it gives you the idea. So let's go back to the editor. The size of this blast is too much, so I'm going to go to my update particle. In my size, I'm going to select the size and I'm going to maybe decrease it down a bit, somewhere like that. Yeah, that's much better. Alright, and I'm going to remove the set color over life because I don't want any alpha or anything. So this is literally just going to be an orange flash that shows up. So now that we are done with the flash, I'm going to call the system, name the system. This entire dotted line is called a system. So I'm going to click on this, name system, and I'm going to name it flash if I can. Name system flash. Great. Alright, so now let's move on to the step 2, which is a lot more exciting than just looking at this blast. What we are going to be doing is creating the plasma beams themselves. And to do that, we have to be using the GPU events that I talked about earlier. So to set a trigger to that event, we are going to update the context of the flash system. And we need to set this trigger, we need to set a trigger event. So how do I do that? I'm going to go to my update particle context. Hit on space. I'm going to search for trigger event, and you'll notice there are 3 types of events. What we really want to do is trigger an event as soon as the flash dies. So I'm going to select trigger event on die. So when this flashes die, we trigger a plasma beam. This is going to then mention that as soon as this flash is dead, it's going to create one particle. I'm going to drag out of this green circle and drop it into my node, and it is going to, and we're going to create a context, GPU context. Now this context, the GPU event context, is very similar to the spawn event itself, or spawn context itself. So we're going to be using the GPU events very similar to how our previous particle system was working. So we'll go ahead and start creating the bare bones structure of the particle system. So I'm going to select here, I'm going to initialize particle, I'm going to go down, I'm going to have a update context, and then right here, earlier we had created an output particle quad, but for the plasma itself, I want to have a more 3D effect to it. So instead of a quad, I'm going to be creating a mesh output. So to do that, I'm going to drag, I'm going to search for mesh, and I'm going to select output particle mesh. So it's going to create a particle that is by default a capsule. Alright, I'm going to go to my initial context, and I'm going to add a random velocity to it. So I'm going to set velocity random, I'm going to add a set velocity random block, which is right here. And I'm going to be adding some velocity to this, because as soon as the flash flies, we need some velocity going up to it. So I'm going to add some velocity on the x-axis, which is going to be anywhere between 50 and 80. And you'll notice that it should, there you go, it should start adding, added angular velocity. That's probably why. Let me delete that. Let's go back in there. Let's set on velocity random. I should be add velocity random in here and adding a velocity of 50, anywhere between 50 and 80. Additionally, I also want to be adding a lifetime to this entire particle that I'm creating. So I also create a lifetime, which is a random lifetime that goes anywhere between 0.03 to 0.04. So you'll notice that, I don't know if you can really see it, but you can see that there is a particle that just kind of flying from, as soon as the blast is done, you'll see a particle is flying in this particular direction. Obviously, we cannot really see the particle, so we want to also do one other thing, which is make sure that the particle is flying from the center of the plasma beam itself. So I'm going to go to my initialized particle, and I'm going to inherit the previous position of my particle. So I'm going to select, or I'm going to inherit position so that the particle is generated from the exact same position as my previous graph. Going to my output particle mesh, I am going to add some color. So let's add some color. In fact, before I add a color, let's add some scale to this so that we can see the particle a lot better. So I'm going to set scale, and I'm going to increase the size of the particle, the height of the particle, by about 15. Much better. So you can see the particle is kind of flying, but it's of course facing the wrong direction. So let's change the angle too. So I'm going to set angle and rotate it by about 90 degrees on the x-axis. There you go. So now you can see the capsule kind of flying from the blaster. Very cool. Finally, you also want to add color. So my favorite kind of blaster color is red. So I'm going to add color, select red, increase the intensity by quite a lot. I think about 7 looks good. And there you go. So now you have the flash, you have an awesome beam that's flying around. That's exactly what we want. Alright, so moving on to the next step, which is explosions. Before I do that, I also want to name this system. I'm going to name this plasma beam. Right, great. Alright. So as soon as the plasma beam is dead, where the lifetime is about 0.03 to even, in fact, make it even more smaller, 0.04, so it dies a quicker death. There you go. Where am I? I also want to add a trigger event, so that the plasma, as soon as the plasma beam is dead, I want particles to be generated. So I'm going to select trigger. And I'm also going to select the trigger event on die. But this time, I want the amount of particles that is being generated at the beginning of this to be about 100, because I want an explosion to happen. Similar to my previous step, I'm going to go to event, I'm going to create a context. I'm going to select an initialized particle. I'm going to select a update particle, and this time I don't want a mesh, I would rather use a quad again. So rather than using an output particle quad, or creating a new one, I'm just going to select this particle, Control C to copy, Control V, and use the same particle node and connect this here, which is a pretty cool way to do repeated steps. So let's arrange this a little bit. So I'm going to select that, move it all the way to the top, and click on A so I can see it a lot better. Fantastic. Alright, so now that we have this, what I'm going to do is we want some explosions. So first things first, I want the explosions to happen in the same place as the previous particle ends. So I'm going to inherit the position as we did earlier, position. And I'm going to add a lifetime to this particle so that the particle explodes and then stays there for a little bit of time. One thing, and then so let's add a velocity random, and we'll make the velocity somewhere to go between 0 and -2 on the x, 0 to 10 on the y, and 0 to 10 on the z. And you should be seeing some particles showing up. Well, they don't show up. What could be the problem? Let's maybe increase the capacity of this a bit so that we can see a lot more particles. Well, let's add, this is probably because the velocity is added, the random velocity is added, but you also need to add some explosions to have some random velocity in the direction in which the blast is happening. So I'm going to select a block and I'm going to add a velocity from direction, and I'm going to create a spherical velocity. And one important thing, which is also most important, is also add a lifetime to this, because that's probably why you're not seeing anything, because the lifetime doesn't even exist. Add a lifetime, and we'll add a lifetime of about, there you go. As soon as we added a lifetime, you can see that there are particles being generated because there was no life at that earlier. And we added a velocity, random velocity. Okay, and you should now start seeing these effects. Let's add, currently the particles are being generated in like going outwards, and we want them to contain them to be inwards. So I have added the add velocity from speed and direction in a spherical way. So let's change the center to be in about 27, and instead of being constant, I want that velocity to be random. So you can see that now it's a lot more random, looks more like an explosion. Let's change the minimum speed to be about 9 and maximum speed to be about 16 so that it feels a lot more natural. One other thing you can also do with the blocks is move them around so that you tell the VFX compiler what should be calculated first before it goes on to the next one. So as with particles, the particles should be flying down and not be going away to some other place. So let's add gravity to our particle. So I'm going to go to update, space, I'm going to search for gravity. Let's add some gravity to that. So as soon as it blasts, it goes down. In fact, I would say it should probably go down a lot more. So let's change the velocity on the y to be -20. Alright, so that looks pretty good. So it blasts, it goes there, it falls down. Fantastic. One thing I do not like is the color of that camera. So color of the explosion, it's all like pretty much yellow throughout. So I'm going to select that. I think the lifetime is too much. Let's actually make it die a little more faster. Let's see. Let's make this 0.1 so that I can see it a lot better. Yes. Compile. There you go. So that should be a lot faster. Let's see. So let's add some color. So instead of add color, I'm going to change the color of the particle as it dies. So I'm going to add color over life. So as the particle dies, it changes color. So I'm going to select this context, and it brings up the HDR gradient editor. Now the gradient editor on the top contains alpha values, and on the bottom is the color that you want. So it currently goes from white to about a little gray, but I'm going to change that to say about yellow. And initially I don't really want any alpha, so I'm going to remove that. And as it dies, I want the color to be a little more orange, orangish color. Let's make this a little more yellow. And of course change the intensity so they can see it a lot better. There you go. Much better. Similarly, let's also increase the intensity over here so you can see the orange particles also flying down and dying. Fantastic. One cool trick I really like, especially when there's a blast, there's usually a flash of white light that happens. You could also use the same trick over here. So I'm going to add a node here, make it all white, increase the intensity to be really high. Oops, that didn't really show up. Let's add that back in here. Yep. And change the color to be white and increase the intensity. So there is a bright flash that shows up. Of course, that's too bright. So let's maybe move it really closer. So when the blast appears, there is a little bit of white flash that shows up. That is very true with a lot of explosion effects that happens. So if you want to really go crazy, you could add a lot more particles in here. So let's actually add a lot more particles. What I'm going to do here is we have a line of stormtroopers. So let's actually create a line of the same FX. So I'm going to go to my flash system. Oh, in fact, let's rename this. Let's name this system first. So this last system that we created, let's select and name it explosions. Right click, name system, explosions. Alright, so I'm going to my flash system, and in my initialized particle I'm going to add a context called line, which is a positional line, and I'm going to spawn in random anywhere between 0 and 17 units, and now you'll start seeing that the particle effects are being generated on this particular line, which is pretty cool. Now if you want to go crazy, you could add a whole number of particles. If you change the spawn rate, and you'll start seeing a whole bunch of particles effects that is being generated. You need to ensure that the constant spawn rate that you have here also is compatible with the capacity of the particles also. So I'm going to change the capacity to also be about 10,000 or 1,000. So you will see a lot more particles, a lot more effects that is coming in. You'll notice that there's not a lot of explosions happening at the other end, primarily because of the capacity problem. So let's increase the capacity of this area to be about 100, and let's increase the capacity over here to be about 10,000. And you'll notice that there is a lot more explosions that is happening over here. Whoa! Alright, that's a lot of blasters coming in and shooting the hell out of these areas. That's awesome. Alright, but this is a very constantly shooting effect. So we can go back to our flash system, and if you want to play around with the rate of the flashing itself, we can create nodes that can control this from an external inspector or from an external editor. And the way to do that is I'm going to drag this little rate, and let's create a sine wave function. And this will now create a sine wave like particle effects, which goes anywhere between minimum of 0 and maximum of 1. So let's make it somewhere between 30 and 40. And the input value could be 1. So if I change the input value, then it changes the sine wave value of what is going to appear here. We can also make this input value be affected by time. So if I go to input, select that, and I'm going to select time. You can have total time. So the frequency of the sine wave is dependent on the total time of our system itself. So you can have external values which are dictating the spawn rate. One final thing is, if you're like me, and you're like, I don't want to open up the VFX editor because I'm not a technical guy. I want someone else to create the VFX graph. I'm an artist, so I only want to go to my inspector and change values right in my inspector. I do not want to open up the VFX graph. You can do that. You can have the artist or the technical artist who created this for you to use the blackboard. So let's say you want to play around with the minimum and maximum value. You can go to the blackboard, which you can toggle up by clicking on the blackboard. Click on the plus sign, and there is a number of values that you can create, or types of values that you can create here. I'm going to create a float. I'm going to call this minimum spawn value, and I'm going to create another float, and I'm going to call it maximum float or spawn value. And I'm going to drag the one other thing before I do that is ensure that when you have created the variable, you expose it As soon as you expose it, you'll see a green dot, which visually tells you that it has been exposed. I'm going to set the minimum value or the default value to be about 30. Maximum value, the maximum swan value, the default value, I'm going to make it about 50. I'm going to drag the minimum swan value and plug it into my min value of my sine wave, and I'm going to drag the max spawn value, if I can drag it. Having trouble with that. Come on, there you go, and plug it into my max. Click on compile if I haven't already compiled it. Now if I go to my inspector and select the Pew Pew VFX, you'll notice now that the minimum spawn value and the maximum spawn value is now exposed in my inspector. So now you can play around with the value. Let's say 1, 2, and this will not affect the editor. So now you have a spawn value of only 1, and that goes between 1 and 3. Or you want to go crazy, you can go 1,000 and 10,000 and woo! Lot of particles that is being generated like crazy over here, and that is pretty much how we have a blaster FX that you can create using the VFX graph. So what we have touched today is pretty much just scratching the surface. We have tons and tons of visual effects that you can use, that you can achieve using the visual effects graph or the VFX graph. And we at Unity have created a VFX sample project in our GitHub page, which contains a number of sample VFX. So let me show a few of them to you. So if you go to the GitHub and get the project, you'll notice that there is a lot of existing VFX that you can start using. So in fact, this is a volumetric thing, a volumetric VFX. If I double click that, the VFX graph for it is automatically available for you if it really does open up in just a bit. So you can kind of figure out how this VFX graph was made. There's other examples like the Unity logo example I showed you earlier, or even this is a really cool example of a morphing mask that you can also play around. This is a hologram. Oops, not that. It's opening up the VFX graph. Let's close that and let's open up the scene. That's the Ellen hologram. Ellen is a character. There you go. You have a nice looking hologram effect that happens. In fact, this is very cool because you can also play an animation of this. So as it's playing the animation, the hologram also changes along with it. Again, created using the VFX graph. Or you can also create this cool looking radar effect that happens over here. So here, so I showed you a lot of FX examples. You can download it from the GitHub page. I'll be the link of that GitHub page is in fact part of the YouTube channel itself. If you look in the description, I have linked it to that GitHub page. So before I conclude and I throw open the door for questions, I want to point out a few things that will enable you to learn Unity during this time. So during this COVID-19 crisis, we are really committed to supporting the community. So we have actually given complimentary access to Unity Learn Premium, and that's for 3 months from March 19th through June 20th. Here you can get exclusive access to Unity experts, have live interactive sessions, and also have on-demand learning resources and more. And there is one other free course where you can learn to code using Create with Code. Create with Code is one of our most popular courses that makes you learn to code through like really fun courses where you create games from scratch using C#. So definitely check it out. So that with that, I conclude. Hope you really enjoyed this webinar. Thank you VIT, Bhopal and Professor Shriram for giving me this opportunity to give this webinar, and I really hope to see you again in another session. So with that, I am open to questions. So if you have any questions, let me know. I will answer them in chat. I'll see them in chat and then answer them over this over the webinar. Thank you so much. Alright, we have one question from Kushagra Prakash. Can we modify the values through script like we can do in Shuriken system, and would you prefer this for small minor particles or the old one? Really good question. You can absolutely change the values of the particle system through the script. The entire visual effects editor or visual effects graph is available as an API, and you can use that API to pretty much access all of the nodes and all of the blocks and all of the context that you're seeing over here to change those. For small and minor particles, I would say it's usually good to just use Shuriken if it's not an overkill, because this is a GPU enabled particle system. You also have to ensure that the build on which you're putting this VFX graph is a time where is a hardware that can support this system. Can the particles interact with other physics particles? This is a question from Supanta Paul. Can the particles interact with other physics elements like collision with other game objects? It can. So if you go to the VFX graph editor itself, you have an option. One of the nodes here, one of the blocks here is called collision, and you can have it collide with a cylinder, plane, sphere, or SDF or a AA box, and that's how you create collisions. That's how you have it react to collisions itself. All right. Yeah, like Sriram said, I would be more than happy to answer questions not only about this session but also about Unity or even about the gaming industry. So one thing I also want to let me also just show you how to go to the GitHub. So if I go to this page, these are all the resources that is available. I should have actually shown this earlier. You can see all of the resources that are available in here, where you can go to unity.com/visualeffectsgraph to learn about general info about the VFX graph. The samples project can be downloaded from here. The VFX Toolbox, which has cool tools which can also interface with other VFX editors like Houdini or whatever, can also work here. And you can also have a read about a deep dive about this VFX graph on this link, which links you to a blog post. If you really liked it, also tweet about it on LinkedIn or Twitter or wherever using this hashtag called Visual Effects Graph, because a lot of our internal Unity folks follow this hashtag, and if you have cool effects to show, it will kind of bubble up on social media. Alright, a question that came up from Spanda Paul again. Are there any plans of integrating VFX Graph with the Universal Render Pipeline? Universal Render Pipeline already supports VFX Graph. You can start using it today. Albeit some of the nodes are not available entirely in the Universal Render Pipeline because of the scriptable render pipeline's capabilities, but it is very much supported and you can start using it today. Good question. Thank you, VIT Bhopal. All right. So Sriram just mentioned that people who have questions to ask will be given gifts or given something, which is pretty cool. By the way, just to keep the channel open or the conversation going on, Universal Render Pipelines is supported by VFX Graph, and you can do a lot of extremely cool effects using URP. Additionally, VFX Graph is also supported on augmented reality devices, so you can have like AR based VFX going on, which is also pretty cool. There is a form that exists currently with Sriram, and if you have any more questions, you can also fill that form up, or you can ask, you can send them to Sriram, and I'll be more than happy to answer them for you. So I'm going to stop this stream right now. I really enjoyed taking this session. I hope it provided a lot of insight into VFX Graph, and I hope that you folks will also play around with the VFX Graph and create some incredibly good looking effects. So thank you so much, and have a good rest of the evening and a fantastic weekend. Bye.